Today's topic is refraction of light. First of all, let us see what is reflection. Okay, suppose this is a surface, okay, and a ray of light is coming this way. This is incident ray, and it hits back or it throws itself back. Then this is called as reflection. It doesn't absorb. This process is called as reflection. Now, before we see refraction, let us see the concept of medium. What is a medium? Medium means it consists of matter. So it could be air is a medium, glass is a medium, water is a medium. But air is a rarer medium, whereas glass and water are the denser mediums. Okay, so now let us go to refraction. Now look at this. This is a glass slab PQRS. Now let's look at this incident ray, the red in color. Okay, now when it is incident, if you closely observe, then actually it should travel the straight path. Instead of the straight path, when the ray of light is coming from air and it goes to glass, now it takes a different path. It is moving, it is changing its direction. And again, while coming from the glass to the air, again it is changing its path. Now this is called as refraction. That means it is the change in the direction of light when going from one medium to the second medium. Now, importance of refraction is, it is only due to refraction that images are formed by lenses or eyes. Let's see an example. Like suppose in a tumbler you have a pencil, okay, and the tumbler is full of glass. It is filled with water. Now the pencil appears to be broken or it appears to be bent. Why so? The reason is refraction. The light bends when it leaves the water, but our brain still believes that light rays travel in a straight line, and therefore it is due to refraction that the pencil appears to be bent or broken. Sometimes if you place some coins in the tumbler in a place where there is a lot of water, then those coins also appear to be raised. Okay, that is also due to refraction. Now, okay, refraction in glass slab. Now consider the ray PQ is incident on the surface AB. ABCD is a glass slab. Now you can see MN is a normal. Okay. Now as you can see from the diagram, ray of light is traveling from a rarer medium to a denser medium. And therefore this ray PQ is going to just bend towards the normal. So if you see, it is bending towards the normal. Now this makes an angle. This angle is called as, it makes an angle with a normal. This ray PQ is making an angle with a normal, and this angle is called as angle of incidence. Now consider this refracted ray QR. Okay, this is the refracted ray, and refracted ray is actually traveling from the surface AB to the surface CD. Now let us draw another normal TU. Okay, now the ray QR is incident on the normal TU, which is yet making another angle, which is R2. Now the light ray QR is traveling from the denser medium to the rarer medium, and as you can see in the diagram, it is moving away from the normal. The angle that is making with the normal is called as angle of emergence E. Okay, but now suppose the glass slab was not there. This ABCD, this glass slab was not there, and if you just consider this ray PQ, then actually it should have taken the straight path. But because it is the property of light that it changes, okay, it changes its direction from one medium to another medium, and that is why you see the bending of light towards the normal and sometimes away from the normal. So this was all about refraction in glass slab. Refractive index. So refractive index actually is a concept which tells us the extent to which the refractive medium changes the speed of light. So basically it compares the speed of light in medium 1 and it compares the speed of light in medium 2. So it's a ratio. Refractive index is written as, if it is 2n1, this is read as refractive index of second medium with respect to first, and it is the ratio of velocity of light in medium 1 to velocity of light in medium 2. That means it is equal to V1 upon V2. Now here I have considered air as medium 1 and glass as medium 2. Suppose I want to compare it and I want to write it as 1 and 2 This is read as refractive index of first medium with respect to second. So it is equal to V2 upon V1. So velocity of light in medium 2 upon velocity of light in medium 1. If first medium is vacuum, okay, if the first medium is suppose vacuum, what is vacuum? Vacuum means it doesn't have any matter. So if first medium is vacuum, then refractive index of medium 2 is called as absolute refractive index and it is written as N. Refractive index can be greater than 1 or it can be less than 1. If it is equal to 1, it means that there is no refraction only taking place. Okay, so it doesn't be equal to 1, but then you can say it can be greater than 1 or it is less than 1. Now, refraction of light in different medium. Suppose now you look at this diagram. Okay, in this diagram you can clearly see now when a ray of light passes from a rarer medium to a denser medium, then it bends towards the normal. Suppose the ray of light is traveling from a denser medium to a rarer medium, then you can see that it is passing or it is traveling away from the normal. Or next, when a ray of light is incident normally at the boundary between the two media, this is medium 1 and medium 2, it is at the boundary, it is normal, okay, then it does not change its direction and hence it does not get refracted. Okay, so refraction of light in different media. Now in the next topic, we will see another topics related to refraction like dispersion or rainbow effect or twinkling of stars.